All right, so let's get going on the last part of today's first meeting. So what we're going to do right now is we're going to start our look at some of the stuff in the textbook. So we're going to start our look at Chapter 1, displaying the order in a group of numbers using tables and graphs. And we're going to look at an important distinction, the distinction between descriptive and inferential statistics. We're going to introduce the idea of frequency distributions. This is going to be our first concept. Sorry, this is going to be our second concept that's going to carry its way all the way through, the first being summation notation. And then we'll take a look at frequency tables, and we'll take a look at histograms, and that'll be it. We'll mention homework assignment number 2, chapter 1, and that'll be the end of the first day. So once again, we're going to start doing something in statistics that doesn't really look like statistics. It's basically going to be about graphing. But once again, remember that we're in the building stages here. We're in the practice stages where we're working on the fundamentals that we need to get automatic to the point where we can do all that cool kind of stat stuff that psychologists use in their work to do statistics. But again, it comes through the practice that we're doing right now with all of this working to make it part of our cognitive muscle memory. Speaking of muscle memory, in psychology, there has been a lot of research done very recently, actually, on the benefits of exercise, the benefits of being physically active, being in competition, as well as a lot of work that's been done on the kind of issues that might deal with competitive sports. So there's actually a very growing demand for sports psychologists to deal with the ever-increasing number of athletes that are trying to reach peak performance. So let's say that you were doing a study on sports psychology and you wanted to specifically study basketball players and see if basketball players are well-adjusted mentally, do they have any mental issues, what are the consequences of being a basketball player? Well, if you were doing that study, you would use both descriptive and inferential statistics. So descriptive statistics, these are the statistics, this is what we're going to be doing for the first little bit in this course. These are the statistics techniques that we use to summarize information, to organize data, to simplify data, to take data from a format that can only be understood by computers and machines and summarizing in a way that our human brains can wrap their minds around it to make sense of the data. So if we were doing this particular study, we might collect data from that child basketball player right there. We might collect data from that college player right there. We might collect data from that high school player right there. We might collect data from that amateur player right there sitting on the sidelines. We can collect data from a number of different individuals. We could have hundreds of different scores, and our human minds will not be able to make sense of any of those hundreds of scores. So what we do in descriptive statistics is we take all that data and we learn tools to summarize them. We learn tools oftentimes of boiling down your scores to one particular number that can make sense to us, that our human minds can understand. So that's the descriptive side, making data, organizing data, summarizing it in a way that we can make sense of it. The other half of statistics is called inferential statistics. And this is where the true power of statistics lies. This is why we do statistics as psychologists. And inferential statistics are techniques that we use to study samples and then make predictions about populations. So an inferential statistic procedure is what would allow us to take a look at our pieces of data, the sample of basketball players that we studied, and be able to generalize about all basketball players, be able to make statements like basketball players in general will experience these mental challenges. Basketball players in general will develop these mental skills. And this is so massively important for psychologists because all of psychology is built on studying samples and then generalizing to a population. And psychology as a science would be beyond useless if we couldn't do this step. So if you studied 12 people suffering from depression, and you were able to decrease all of their depression, right? You were able to cure all 12 of those with a treatment. Without inferential statistics, that is where that story ends. And if somebody calls you up and says, you know what, I'm running a clinic, I got 1,000 people suffering with depression in my clinic, do you think your treatment will work for those? Without inferential statistics, your answer is, I don't know. Maybe it will, maybe it won't. It worked for my 12, I can tell you that, but without inferential statistics, we can't generalize. So we're going to get to that in the second half of the course, but that's what we're working towards. That's the big, powerful thing that stats allows us to do in psychology. All right, so descriptive statistics first. Frequency distributions. Frequency distributions is a way of visualizing data, again, so it makes sense to our human minds. This is a frequency distribution graph right here. And what a frequency distribution is, it's an ordered listing of your scores for each possible value on a particular variable. So you have all of your scores, you order the listing, and you count the number of individuals that have each particular score. So we have a frequency distribution right here. We can zoom in on it a little bit. And let's say that I gave students a test, and the test was out of 100. And this were the scores that were achieved in that particular class. This is an ordered listing of the scores, right? It goes from lowest scores all the way up to highest scores. And it's also letting us know how many individuals achieved each score. That's a frequency distribution. So rather than having just a random jumble of scores, we have scores organized in terms of an order and how many individuals achieved each score. So we have the order of the scores there on the x-axis. And the way to read a frequency distribution graph of this kind, the way I like to think about it is think of this as an apartment building where people live. And one person lives on each floor. So in this first part of the apartment building, we got 2 people living there. We got 2 people that scored between 50 and 59. In this next apartment building, we got 1, 2, 3, 4, 5 people living there. That's why the bar is 5 stories high. 5 people scored between 60 and 69. Between 70 and 79, we got 4 people living in that apartment. Between 80 and 89, we got another 5 people living in that apartment. And then all by their lonesome, over here in 90s to 100 land, we got 1 individual that scored that high. So that's the way to think of a frequency distribution. It's individuals stacked on top of each other. The height of the bar tells you how many people got any particular score, and it's ordered in a way that it can make sense to you visually. So if I looked at this and I was saying to myself, anybody that got less than 70, I'm going to set up a tutoring session for them. How many people am I going to have in my tutoring session? Well, immediately I know it's these people in these 2 apartment buildings right here. And I got 1, 2, 3, 4, 5, 6, 7 individuals. 7 individuals, very quickly, easily understood information. You can make decisions about a lot of data when it's organized properly. All right, so that's your frequency distribution intro. So you can make a frequency distribution. Basically, there's 2 major ways to structure them or report them. One is in table form, and the other one is in graph form. So you'll see frequency distributions in both table and graph form. We're going to start off with table form and we actually just showed graph form as an example. We'll talk more about that in just a moment. All right, so let's consider the following 20 scores. So one thing I'll point out here, that N, that large N, that indicates the number of scores. So when it says N equals 20 scores, that means that we got 20 scores. That means that our raw scores these X scores here, there's 20 scores in that X, right? So that's what the N indicates. So we got 20 scores on a 10-point quiz, and those are the scores right there. And again, they're jumbled, they're in a mess. If I showed that to another professor and I said, how are my students doing? They would take a look at that jumble and say, I have no idea, I can't tell you. So what we're going to do is we're going to construct a frequency table that has those scores. And a frequency table has two main columns. It's got one column labeled, and I hate this, labeled X for score. It's got another column labeled F for frequency. So typically you won't see the English words there. You'll just see X and you'll just see F. Make sure you're reading it as F for frequency. And then very importantly, make sure that you're reading this one, not as the scores, but the possible scores. And that'll become apparent why in just a moment. So think of it as the possible scores, because that's what it is. It's a listing of the possible scores. So in this column labeled X, which in a frequency table we call the possible scores, we have the possible score of 10. You can get 10 out of 10 on this quiz. We got the possible score of 9. You can get 9 out of 10. That's a possibility. You can get 8 out of 10. You can get 7 out of 10. You can get 6 out of 10. 5 out of 10. When does it go automatic? 4, 3, 2, 1 out of 10. You can even get 0 out of 10, right? Those are all the possible scores. It's important to remember these are not the actual scores. These are the possible scores. This is what people could have gotten on this quiz. All right, so now we're going to construct a frequency table. We got the one column with possible scores. Now we have to figure out the frequencies. So let's zoom in on those numbers a little bit. And what we're going to do is for each possible score, we count out how many people actually achieved that score. So we take a look at that series of 20 scores and we say, how many people scored 0? Well, nobody scored 0 out of 10. So for the frequency, we put in 0. And this indicates that 0 individuals scored 0 out of 10. We take a look for a score of 1 out of 10. Nobody scored 1 out of 10. So the frequency for a score of 1 out of 10 is 0. 0 people scored 1 out of 10. We look for 2 out of 10. We got one individual right there. We got a second individual right there. Nobody else scored 2 out of 10. So the frequency for a score of 2 out of 10 is 2. 2 people scored 2 out of 10. 2 people live in the apartment, 2 out of 10. We do the same thing for 3 out of 10. We got 2 people that scored 3 out of 10. So for the possible score of 3 out of 10, we put in a frequency of 2. And we continue building as we go through each of the possible scores. So we have 2 individuals scored 4 out of 10. We have 2 individuals scored 5 out of 10. We have only one person that scored 6 out of 10. So that frequency is a frequency of 1. We have 4 individuals that scored 7 out of 10. So that frequency for the possible score of 7 out of 10 is 4. 1, 2, 3 individuals got 8 out of 10. So we continue to build and update the frequency tables depending upon how many people achieved each possible score. So we got one individual that scored 9 out of 10. We put a frequency of 1 into the row for 9 out of 10. And then finally, we got 1, 2, 3 individuals that scored 10 out of 10. So that gives us a frequency of 3 for scores of 10 out of 10. Any questions so far? All right. So one thing that you can always do to double check your frequency tables, if you did it correctly and you summed the frequencies that you have in your frequency column, that sum should be the same as the number of scores that you have. So every single score goes somewhere in this frequency distribution table. It goes in only one place. So everything in its place and a place for everything in a frequency table, which means that when you sum your frequencies, you should get the same number as the number of scores that you have. All right, and then one last thing before we go on to the next kind of table. Please, 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 I'll mention this one more, two more, however many more times. This column here is designed to trick you. It's designed for you to fall into a trap. And it's designed for you to forget what this column is. I really wish statisticians said, let's call this possible scores. They don't. They labeled it X. They call it the scores. So make a note somewhere in your notes, in your mind. Call it the possible scores. Because what's going to happen is that you are going to be working with a frequency table, and it's going to say, what is that? Calculate that. Given this frequency table, calculate that. And what this is this is the sum of the scores. Meaning that you have to go 8 plus 5 plus 3 plus 2 plus 8 plus 7 plus 4 plus 8. All the way through those 20 scores. But when you see a frequency table, like I said, this column here is there to trick you. Do not fall into the trap where you say, oh, it's the sum of the scores. Oh, wait, there's the scores. All right, here we go. 10 plus 9 plus 8 plus 7 plus wrong. That's not what it's asking. So just remember, these are the possible scores. They're labeled the scores, but in a frequency table, possible scores, not the actual scores. So if you're asked for the sum of the actual scores, don't fall for it. Don't start going, oh, 10 plus 9 plus 8 plus 7 all the way down to plus 1 plus 0. All right, you'll hear that PSA probably a few more times. All right, so sometimes, especially when you're dealing with large numbers, like if your numbers get into the hundreds or the thousands, a frequency table can look really messy if you have actual frequencies. So you can also do the scores using percent. So here is the formula for percent. You take each score's frequency, you divide by the number of scores, you multiply that by 100, you get the percent. So sometimes you'll also see frequency distribution tables with percentages instead. So 3 divided by 20 multiplied by 100, that gives you 15%. So 15% of individuals scored 10 out of 10. And then you can calculate that for all the scores going all the way down. And once again, outside of rounding error, if you sum up the percents, you should get to 100. Sometimes you'll get, because of rounding, you get to 99.9 or 100.1, whatever it is. But it should be close. It shouldn't be too far. All right, any questions on frequency tables? All right. So let's end up, in today's class, we'll take a look at frequency graphs, also known as histograms. So you can represent the exact same information that we had in this frequency table in a frequency graph. Sometimes it's easier to work with a table. Sometimes it's easier to work with a graph. I like to visualize my data. I like graphs. Other people need to do some quick calculations. They like tables. So for example, a table is really easy to work with if you need to answer a question like, how many people scored 8 or higher? Table is super easy. You go, all right, 3 people scored 8, 1 person scored 9, 3 people scored 10, 3 plus 1 plus 3, that's 7. 7 out of 20 people scored 8 or higher. Really easy to use that on a frequency table. However, when you construct a histogram, a frequency graph, then you get a kind of visual picture of the same information. So this frequency graph here, this is the exact same information that we had in that frequency table. It's just in a different format. So again, we have the possible scores, right? Not the actual scores, but the possible scores. And then each of these bars is that apartment building with people living inside it. And 2 people scored 2 out of 10. 2 people scored 3 out of 10. What do we got for 7 here? We got, it's hard to see at this angle, 4 people scored 7 out of 10. 3 people scored 10 out of 10. And with this, you can kind of very quickly get a visual of how your scores are doing. So for example, here we can see that there is a large group of individuals that are not doing well, right? We got 8 people out of 20 that are not doing well at all on these scores, that's something that wasn't as apparent in the frequency table, but immediately kind of pops out at you in this frequency graph. So you can do a frequency graph, frequency table, they have pros and cons, but just remember they're showing you the exact same information, possible scores, and how many individuals achieved each of those possible scores. So that's a histogram right there. You can also do a bar graph as well. Those two are literally almost exactly the same. The reason they both exist is that technically, if it's impossible to score between two scores, you should use a bar graph. So if you can only score a 4, or you can score a 5, or you can score a 6, so if this is a graph of how many children do people have, do families have, you can't have 2.5 children, right? It's either you got 2 or you got 3. That would be a bar graph. But really, for all intents and purposes, that's more of a communication tool and less of an actual statistical tool. So just be aware of that. If you see a bar graph and a histogram, that's why those two exist. They give you the same information, it's just for two different kind of situations. All right, any questions about frequency distribution table, bar graphs, histograms? Yep.
If it is impossible to score between the scores, use the bar graph. If it is possible to score between using histograms?
Yep. Okay. So if we were doing something like the height of trees in meters, right? This would be like 2-meter trees, 3-meter trees, 4-meter trees, and you can do 4.5, you can do 4.75. I'm showing my Canadian here because I went meters. You can show those different in-betweens. It's possible to score in between, so that's when you would use a histogram like this.
And when you write a range, or the 4 just designate like 4 and up?
You would probably do a range is one way of doing it. Occasionally, and we'll see these later on, if you have a number of different scores, you can actually graph the scores, and what you end up with is like a smooth line. So you will see histograms, the most famous of which is the bell curve, where you see like, a curve that looks like that. This is a histogram. It's a graph of the possible scores down here. And then the height of each of these lines is how many people scored that possible score. So that's one of the things that I'm hoping will become very automatic as we go through this. So right now, just kind of, we'll lead with this kind of idea. Right now, when you look at this histogram, I fully expect everybody here right now to have to remind themselves what this is all about, right? So I fully expect everybody to have to stop and think and go, okay, scores, not really, they're possible scores, but they're ordered, but those are the possible scores. And what do the bars represent? Well, they're kind of like apartment buildings, so it's how many people got each one. So the higher the bar, the more people, the lower the bar, the less people achieve each score. I totally expect everybody to be at that point right now. At some point, though, in the next coming weeks, when a histogram like this pops up, you will immediately know what it means. You will immediately be like, oh, okay, I get it. Lots of scores here, not that many scores here. Like this distribution here. Lots of people score in the middle, not so many people score at the end. So I expect you to get to that point. You might not be there yet, but as you go through your homework, your post-tests and things like that, and we start working through the histograms, hopefully at some point when a histogram pops up, you'll say to yourself, oh, okay, I know what this is, rather than have to remind yourself possible scores, height of the bars equals that. So that's where you should be right now. If you're not, we only got about 10 minutes this day for kind of end of class stuff. But for example, if histograms at this moment still make no sense to you, if you're looking at the frequency distribution table and you're like, I don't understand what those two columns mean, today would be the perfect day to call me over after class and or come by the office hour to make sure that you have that understanding. If you're at the point where you're like, okay, I get it, possible scores, that makes sense. Height of the bars is how many people get it, that makes sense. That's kind of where I'm expecting everybody to be at today. And as you go through your practice, your homework, your post-test for Chapter 1, you'll do frequency distribution after frequency distribution. and you'll get more automatic to the point where later in the course, if we pop something like this up, you'll find that you don't even have to think about what it means. Much like when you're reading, you don't have to think about what each word means. It's just kind of automatic. You'll be able to read this and say, all right, I get it, frequency distribution, possible scores, how many people on each, and you'll be able to handle the larger concepts. All right, any other questions about what we just covered today? Okay, so once again, just a reminder, we have your first pretest is coming up. That's going to be pretest 2. That is due by tomorrow by midnight. So again, we haven't covered chapter 2 yet. This is your sort of warm up, get in there. Feel free to make errors. You have multiple attempts. If you don't get 100% on the pretest, know that you do have the ability to make up those points using the mastery points. So don't get discouraged, but definitely do the pretest. Give it that honest try. It'll work its way into your cognitive abilities. That's why we do this. Also, you are now ready to do homework assignment number 2 for chapter 1. So homework assignment number 1 is the MyStat Lab tutorial. Make sure you go through that. Homework assignment number 2 is working on chapter 1. It's working on these frequency distributions. So again, check in your syllabus, check with your MyLab. Please do not miss your due dates. It's your responsibility to know your due dates. This automated system will grade your scores right at the due date. So stay on top of those. Summer session moves quick, but you know, the stats course I teach it during the summer because I've been highly successful teaching it during the summer, but just know it moves quick. Know your due dates and stay on top of those. All right, so I told you this first class is going to be a weird one. It's a little bit out of whack because we have to do a lot of fundamental kind of groundwork here. So normally we'll have more time left over at the end of class. We got 7 minutes right now, so if you're all statsed out, if over 3 hours is enough stats for you, I know it's I'm getting there myself. Feel free to call it an early day. That's all I wanted to cover for today. On the other hand, if you have any questions, I'll be here until 12:15. Call me over, let me know. And if you need to stop by, my office hours will start at 12:30 today, just upstairs, 2163. And again, stop by if you need any assistance. But other than that, that's all I wanted to cover for today.